Next problem. Predict the effect of decreasing the temperature on the position of the following equilibria. Decreasing the temperature. So we're just going to predict, is it going to shift left or right if we decrease the temperature? Okay. So on reaction A, we see that the energy term, which is heat, okay, heat is a form of energy. Here, heat is a product. So this is exothermic reaction. And if we decrease the temperature, it's like we're decreasing the concentration of heat. And here, heat is a product, so that would cause us to, remember, you replace, anytime you remove something or decrease something, equilibrium will shift to replace the thing you decreased or took away. So it's going to shift towards the product. So equilibrium will shift right here. On the next reaction, we see delta H is positive, which means that heat, I'm going to zoom in, is a reactant. Okay? So if heat is a reactant and we decrease temperature, it's like we are decreasing the concentration of a reactant, and it's going to now shift back to the left to replace heat. Okay, lastly, delta H is negative. So what that wants you to infer is that this is an exothermic reaction, which means that heat, or the energy term, is a product. Okay, so it'd be CO2 plus hydrogen plus heat. Those are our products. Now if we decrease temperature, it's like we're decreasing the concentration of a product, which matches our scenario in A. Equilibrium would shift to the right to replace the thing we take away, which here in this case is the product heat. And that's it for this problem. Alright. We'll do this next problem. This actually is a problem similar to some stuff you should have done on the Chapter 9 homework. Or if you've yet to do the Chapter 9 homework, this will help you. Okay. Which of the following solutions is more concentrated? 2.5% mass per volume of NaHSO4 or 0.25 molar. So the way you go about these problems is you have to put them in same units. Okay? We know the equation. I'm going to write out the equations for both of these things. Mass volume percent is grams solute per milliliter solution times 100. Molarity is moles of solute per liter of solution. So because we have different units in these equations, we can't make a comparison until we do some math here and convert some stuff. It's like comparing apples and oranges because we have different units. So it really doesn't matter which way you go. I could take the molarity and I could convert it to a mass volume percent, or I could take mass volume percent and I can convert it to molarity. Okay, so I'm going to take the first one, mass volume percent, convert it to molarity. Again, it doesn't matter. You can do it either way. So if I'm going to take mass volume percent and convert it to molarity, that means I have, first I'm going to get rid of this 100, okay? I'm going to divide both sides of the equation by 100. It'll cancel out over here, and when I do that, I have 2.5% divided by 100. That gives me 0.025, and the percent goes away. Now, this equals grams solute per milliliter of solution. Okay? So essentially here is maybe the most difficult part of the problem. We know that our concentration overall should be a 0.025, or it should match 2.5%. Okay, but we don't know the number of grams or milliliters. We just know that it has to give us a value of 0.025. So what you do here is you essentially plug in your own numbers to give you this value of 0.025. Okay, and again, I understand this seems a bit ambiguous, and because I don't know if I worked a problem out like this in the lecture. So what we would do, what I like to do is I like to just assume, some nice even numbers here. If we have 100 milliliters, okay, if we have 100 milliliters, then we can plug in what number divided by 100 would give us 0.025. Well, we actually just did that math. It would be 2.5 grams. Okay, if we have 2.5 grams of solute and 100 milliliter solution, we will get a concentration of 0.025, which is the 2.5%. Okay, so again, I plugged in my own numbers here, but it matches the percent concentration we have, the mass volume percent. So now that I know that I have 2.5 grams of solute and 100 per 100 milliliter solution, you could have plugged in different numbers, as long as when you do the math it gives you 0.025. It doesn't matter what these numbers are. Now I want to get this into molarity. I know that my solute, be a little more specific here, is not just any random solute, it's sodium HSO4. Okay, so what I need to do now, I'm trying to convert, remember, units of grams and milliliters to moles and liters. So first I'm going to convert grams to moles, so I need a molar mass. So I'm going to look up the molar mass of our compound here. And if you look that up, it's 120.06 grams of NaHSO4 for every 1 mole. And grams will cancel out. Goodbye to the grams. And now I need to convert milliliters to liters. So I'm going to keep going all in one step here. 1,000 milliliters for every 1 liter. And if I do that, milliliters will cancel out. So now I just do my math. We will do 2.5 divided by 100 divided by 120.06 times 1,000. And what we find is this gives us a molarity of 0.208, but I'll round, I'll say 0.21 molar. And the question is, which of the following solutions is more concentrated? So I have either 0.21 molar or 0.25 molar. Okay, remember this one right here was the 2.5%. And when we converted that to molarity, we find that it's less concentrated than 0.25 molar. Okay. So that's how you do this problem. This is definitely a challenging problem. And like I said, you could have taken molarity and converted to grams per milliliter and solve your percent that way. Either way. So that was our answer. That one's more concentrated.